Have you ever wondered why you can find pictures of people skiing on a mountain in Africa, but just a few miles away it's absolutely scorching hot? Well, today we're going to unlock the secrets behind our planet's wild temperature swings.
I mean, really think about that. You see a picture of Mount Kilimanjaro, right? Its peak is totally covered in snow, yet it sits right near the equator. It seems like a simple question, but the answer, well, it reveals three fundamental rules that shape our entire world's climate.
Okay, so our journey begins at the equator. We've got to start here to tackle the biggest climate influencer of them all, latitude. And simply put, that's just how far north or south you are from that imaginary line wrapping around the middle of the Earth.
It's a really simple rule, but it has a powerful effect, and it all boils down to one thing: the angle at which the sun's rays hit the Earth.
Imagine the sun's energy is like a flashlight beam. At the equator, that beam is shining straight down, creating a small, intense hotspot of heat. But as you move towards the poles, that same beam hits the Earth at an angle, so the light and the heat get spread out over a much wider area. The key takeaway? Less focus means way less heat.
And this chart illustrates the point perfectly. Take a look at the red line for Salvador, Brazil. It's right near the equator, and you can see it stays warm all year round. Now trace your eye down to that purple line for Barrow, Alaska. It's way up in the Arctic, and it's just consistently cold. That huge difference is all about the angle of the sunlight.
All right, for our second rule, we're changing direction completely. We're not going north or south anymore. This time, we're going up.
This is a classic riddle, and the answer completely changes how you might think about heat. I mean, you'd think being closer to the sun would make you warmer, right? But that's not how our atmosphere works. Not at all.
So here's the secret. The sun doesn't really heat the air directly. Its rays pass right through the atmosphere, hit the Earth's surface, and heat up the land and the water. The ground then acts like a giant radiator, warming the air from the bottom up. So what that really means is the higher you climb, the farther you get from this giant natural heater.
And there's even a handy rule of thumb for this. For every 1,000 meters you climb in altitude, the temperature drops by about 6 degrees Celsius. That's around 3.5 degrees Fahrenheit for every 1,000 feet.
Now, what's really fascinating about this slide is how clearly it shows this principle in action. Look at La Paz and Concepcion in Bolivia. They're at almost the exact same latitude, so they get the same angle of sunlight. But La Paz, sitting way up high in the Andes Mountains, is significantly colder all year round than Concepcion, which is down in the lowlands. Altitude makes all the difference.
Okay, for the final piece of our climate puzzle, let's head to the coast, where the relationship between land and sea dictates the weather. You've definitely felt this yourself at the beach, right? On a hot day, the sand can be absolutely scorching, forcing you to hop around, while the ocean water, just a few feet away, can still feel refreshingly cool. This simple experience, well, it reveals our third big rule.
It's all because land and water have very different thermal properties. Land absorbs and releases heat super quickly. Water, on the other hand, is like a giant thermal battery. It takes a really long time to heat up, but once it's warm, it holds onto that heat for a long time.
So how does this play out in the real world? Well, the ocean basically acts like a giant climate stabilizer. In the summer, winds blowing off the cool water prevent crazy heat waves along the coast. And in the winter, that same ocean releases all the heat it's stored up over the summer, and those winds provide a warming effect, keeping the coast much milder.
So, let's put it all together now. We've looked at three huge forces that pretty much dictate temperature all across our planet.
These three major forces, your distance from the equator, your height above sea level, and your closeness to the sea, they all work together in this constant interplay to create the incredible diversity of climates we see across the globe, from tropical rainforests to icy mountain peaks.
Of course, the story doesn't quite end there. Climate is incredibly complex. You have other huge players in the game like cloud cover, powerful ocean currents like the Gulf Stream that move heat around like a global conveyor belt, and even our own cities, which can generate enough heat to become heat islands, measurably warmer than the countryside right next door. And this brings us to a final and really crucial question. We've just learned the fundamental rules that govern our planet's temperature. But in a world that's changing so rapidly, how will these rules bend, or maybe even break? The answer to that is going to shape the future for all of us.